We've already talked about the union and the intersection of sets. Recall, the intersection wants just the common elements, so that would be in this region. The union is interested in everything in both sets. So it could satisfy A only, could satisfy B only, and because we use the inclusive or, if it overlaps, it's good. So this is what the union would look like. Okay. So let's get rid of all that. And now we're going to talk about our last idea. What if I asked you to show where not multiples of 2 would live? Let's create our general Venn diagram here. And we can start with the shading. You might have an idea that not multiples of 2 here. But you'd be partially right, because what you're forgetting is the rest of the universe. Things like 1, 5, 7 are not multiples of 2. So what we're looking for with this is everything else in the universe that is not a multiple of 2. So the correct regions to shade would be everything here in blue. All of this indicates not multiples of 2. Not is the key word for something we call the complement. The complement is everything else in the universe that is not whatever is in question. So in this case, everything else in the universe that is not a multiple of 2. To notate this, multiples of 2 are shown with A. Now you might think to negate that we would draw a line through it, and that would certainly make sense. However, we use a little bit different notation. We use this little prime. It's read as A prime or A complement, and it's understood then that we want the complement of A, which in this case would mean not multiples of 2. If we look then at not multiples of 3, we could denote that as B complement. So multiples of 3 are shown as B, and then if we want to negate that or look for the complement, we put that little prime on there. And then where would the elements live that are not multiples of 3? Well, those certainly are not multiples of 3, but do not forget about the rest of the universe. The thing about a complement is that the complement, so everything you see in blue, combined with the event, which in this case I'll show in red, together the complement and the event itself will make up the entire universe. So you can see the complement in blue and the event in red, and together that fills in the entire rectangle. That wraps up all of our terms and related to sets as well as the notation. In the next video, you're going to learn how to do some counting.